My name is François Fouquet. I'm the CTO of DataThings. I know a few of you, but not everyone. So thank you for coming for this first GreyCat Meetup. We try to keep it not so formal meeting and something that we do regularly to exchange with people which are either interested, either user of our technology, and it's also a way for us to receive a feedback about where these kind of technology are steering in the future. I will do a very small introduction talk, and then I will let Assad show you the demo for one particular case study. So I will try to be as brief as possible, but still that you have a bit of context to have an idea what we are talking about. The talk today will be about knowledge graph, MCP and AI. This is of course a topic which shake our community quite tremendously the last months. We thought it is quite important that we try to position ourselves within these trends to explain what we can do and not do with GreyCat compared to this new usage. And we had the chance to add one case study around text indexing and documents, which we went through proof of concept. So, and this one we can detail to you to show you where it can go with the mix of technology. Fine for everyone. It's a meetup. You can interrupt me whenever you want, ask questions and so on. We will try to make it not so formal. In terms of agenda, I will present a few slides, then Assad will talk a demo, and then we will have kind of a question and answer where you can move around, take some pizzas, have some drinks, and then we can kind of have some discussion. We prepare a few, but also come with yours. Okay? The goal of today is to speak. So even if I start to speak, even if it looks like a keynote, it's not. Interrupt me. We want to share the progress of development of our technology. We want to also share your feedback of what you currently need, because the goal of this kind of event is that we can see where we could develop tech in a way that this could be useful for you, for your case study, and also to see, regularly where you could have some pain points and where we have to think about developing tools for it. We will try to repeat this every 2 months. It's not a promise. We'll try to. Okay, so it's the first that we do. So apologize for everything which is not perfect. It's let's say the training session. The agenda. A few words about GreyCat, what it is, what the connection with AI. So this demo, which is a knowledge graph for legal document for the European Court of Justice, we will speak about vibe coding and the link with GreyCat and show you what we do for this. Then we will have a few release news. It's not very long here because this is the first time again that we do the event, and the discussion and question and answer session as planned. Fine for everyone? Good. The very, very fast intro. I mean, GreyCat is quite, let's say, a large technology in the sense that we are doing a few things here. I just want to give you enough element context that you understand what DataThings is doing, for what kind of case study, and why we are speaking about the Court of Justice today. At the core, GreyCat is just essentially doing this. This is a very, very high level overview, but our goal is to ingest data with different nature, especially time series, which come most of the time from sensors, textual, which come from most of the time from legacy relational database, but could be also any kind of log of transactions record on subsystem. We take geospatial data. Other people name it geographical information system, and we especially take as input vectors, which are the results of everything around AI and everything about embedding information into something which is compact and which represents a fingerprint of an information. So vector is definitely tremendous important now data input for GreyCat. GreyCat is active. That was there is this loop which run, and the goal of GreyCat at the end is to enable agent and dashboard. So basically GreyCat crunch the data, process it, store it in an efficient way, in a way that we can enable this kind of API and MCP connectors to create tools for others. And this is what we have to do. Very concretely, a very brutal slide of code. Why we do this? Bonjour. Why we do this is because this looks like a fancy slide, okay? Everyone is doing this with a complex infrastructure, but at the end, to do this kind of system, it is a very simple snippet of code. And this slide here is not a fantasy. This is really an implementation that could run. It's basically a main function at the end, which has a scheduler. The scheduler scraps the data regularly, let's say every 30 seconds. We ingest it into some indexes, which is this part, which has a few data types to basically tame the complexity of having different data sources. And the magic is, at the end, we can offer a few API, write some imperative code, which can eventually even orchestrate a few AI algorithms, such as an embedding thing. And that's it. It's as simple as this. This is the way we do pretty large applications. So I just have a few to illustrate what we can do with this. We did the implementation for Kopr, and we have the chance to have one of the guys which helped us to make it running for real here. So thanks for being here. So Kopr is 1.2 million assets. So it means that the textual information originally is already a big context. It's aggregated data from 350,000 smart meters. And long story short, it's a very large graph. The time series overall represents more than 192 billion of data points. So yeah, it's quite a large graph. And how it looked like at the end, it looked like this, an application with a dashboard which has different time series, something like a Google map of the smart meter of the Luxembourg, all the interconnection point, and then everything about overlaying the KPI, so the heat map information about the load of cable, the over, under voltage, all this kind of thing is what we have to empower here. So essentially, we receive the data, we crunch the data as fast as we can, then we offer the API, and this is one of the ways to see it, which is the dashboard. One of the case studies. Another case study is we have TGRAIPH, where we do commodity trading risk analysis. So it means we ingest different data sources from country, especially the trades and the amount of commodities which are exchanged. For example, some seeds, some chicken, some steel, which are exchanged between the country. We exchange all the trades, and we build some prediction system that we could help the people to understand who depends on what, and especially if there is a problem with the geopolitics. And unfortunately, the recent events is kind of a good way to illustrate why it could be useful. We can create a lot of APIs and MCP tools to basically give access of this kind of pre-crunch information to different ways. One way is to build this kind of dashboard, so it goes very, very fast here, but because it's not the goal of today. So simply speaking, this is a way to navigate through the link of the different countries, how they trade, how it fluctuates, and to simulate things such as if we cut another route here, what would be the impact on other country. Okay, so it's different application, and the goal of this kind of very fast screen sharing here is just to illustrate the fact that despite the fact that this is very different application at the end, this is still a knowledge graph on the core, and this is all enabled by GreyCat. The thing is, it's not so simple, and that's why I wanted that Asad show you what we did with document, because all of those applications are about mixing graph, time series, and this is what we do for Kopr. It's also what we do with TGRAIPH. But for document, it's not so simple. For document, we have to orchestrate with vector embedding and search index, and this is what we did new with this new project, and so we wanted to share this with you today. Fine? So I'll lay the floor to Asad.
So, hello everyone. I'm Asad Mawad. I'm one of the co-founder at DataSings and head of AI and machine learning. So the meeting today, I will show you the demo we did with the Court of Justice. And the thing is, before we did the demo with them, the situation is that they had several layers of technology. One of them is to enable graph and relationship, and classically they use some kind of Neo4j, PostgreSQL, GraphQL. This is a classical technology just to model the relation between entities and node. A vector search, basically to index text and to be able to search quickly inside the big amount of indexed text. triple store and knowledge graph, a time series to index the document and time, because, for example, the same law can have different iteration, and each iteration has a different date in time. And if you open a court ruling from 1970, maybe the law was different, and you need to put the court ruling according to the law at that moment in time and not according to the law today. So you have this time aspect. And of course, you have a layer of orchestration, basically to get the data from all these kind of sources and prepare things together to offer tools and API and MCP tools for the AI. And they try to do this over 3 years. They have some stuff that was working. They have some part of the technologies that were in place. And the problem that they faced is that they have 5 systems to install, 5 systems to synchronize, 5 systems to secure, because, for example, the case that were already judged and it's becoming a public knowledge, everyone can access this information, but the current case that is being under investigation, no one should be able to access this information, because otherwise they can influence the court or do something. So you have as well problem of access control, problem of security, problem of synchronizing all these systems together, problem to back up, problem to maintain, and the infrastructure. All of this, you can imagine how costs add up. The more you add system, it's not only a linear cost that will add up, but sometimes it's exponential cost, because you need as well to integrate one system with all the remaining, especially if you need to back up and synchronize the data between each other. And on top of that, they wanted to put an AI layer, which basically can connect to any kind of system, and at the same time ensuring access control, ensuring security, ensuring synchronization, ensuring that the AI has access to all this information. Plus, for example, maybe one document now is sensitive, but once court take an action and the case is closed and it's been 3 years, so basically you cannot open it anymore. Maybe with time this case will become public. So the access control need to be changed within the time, so it's very complicated thing to set up. So what we did with proof of concept is to show them that GreyCat can replace all of this stack. So because GreyCat has the capability of a graph database, it has a capability to index node and relation between each other. It has a capability of vector database, because you can index in vector as well in GreyCat. It has a capability of triple store for knowledge graph to say, for example, this case has been judged by this judge and this kind of knowledge representation and ontology. GreyCat is temporal graph database, so it has as well time series capability, so you can index the document in time. And of course, since it's a web server, we need the security and the orchestration, which is as well offered by GreyCat. And as you can see from the proof of concept, the goal would be to evaluate if GreyCat can replace all this technology and simplify the stack and make it much simpler, make it easier to maintain, easier to evolve with time. So single license, single hardware, single backup, small team, and unify everything together, have everything clear in one place. So this is the goal, okay? And why this matters to AI? Because basically connecting AI directly to raw data doesn't work, because they have a big database of all the court ruling and all the laws, all the documents. Plus, I mean, you can do it, but it will be too slow. And now when we see how agentic AI is moving forward, for example, when you ask any query for an agentic AI, the AI will use maybe 20 or 30 or 40 different tools in order to reach to the answer. And if each tool call will take 2 seconds or 5 seconds or 10 seconds to reply, then this add up and then it becomes unusable. No one likes to try something and then go for 30 minutes before getting an answer. So, the speed is very important. It's too costly if we want as well to ensure that the AI doesn't access sensitive information. It's too dangerous as well. Okay, so these 3 aspects matters a lot, and this is where GreyCat sits in between. So basically, GreyCat ingest all this data, create all the different index in terms of nodes, relationship, time series, and expose the tools or the stuff needed for the AI to do its job in a fast way, in a cheap way, in a safe way. Okay, so one of our marketing talk to the Court of Justice technical team was the 6 reasons why to choose GreyCat. First, it's sovereignty because it's made here in DataSyncs in Luxembourg. It's 100% EU made. There is no dependency to any third party. So no US cloud dependency. So GreyCat itself can be deployed locally on-prem. It's a unified stack, which is very important not to manage 5 different technology stacks. It's AI ready because anything you do in GreyCat can be exposed as well to AI if you want. It's ultra fast, and all of these aspects we will show you in the demo. Okay? Hello? And the security aspect, of course, because as I said, once everything is in one database, it's easier to maintain the security aspect because the access control is the same. If you connect from the front end or if you connect via the chat will inherit your security, and then you will have access to the same document. Cost, because since it's here we are selling one license, for sure instead of 5 different licenses, it will be cheaper. And maintainability is the same, because if you have a code base that is run in one system, it's much better to maintain, easier to maintain than having 5 different systems and trying to synchronize them. So as Francois discussed before, how can we do this with GreyCat? We have this MCP is a first-class citizen thing in GreyCat. We can just have @tag MCP, and the function becomes accessible to the AI. And we have the embedding, which is a kind of a specific index for embedding text. And this allows the semantic search, the text search, the vector search. Yeah.
Maybe just to add, I mean, because the reason why we show code, I mean, we know that not everyone is a developer, but it was quite important for us to show some concrete thing. At the core, GreyCat is a mix between a database and execution programming language. So if you see it, it's just like classical programming language, imperative style, where if you execute a function, you are in the database. Which means you can reach any point of the database based on the indexing. And the killer feature we did here is just to add this tag here, MCP, which means that now, whenever GreyCat exposes HTTP server, every information from the typing system, the parameters, the type of the parameters here, even the documentation of the parameters, the documentation of the function here, is exposed as an MCP protocol to an AI chatbot, which means that now this is a tool available. And since we are close to the database, this tool is not only stateless, it's stateful. This tool can fetch data and which is prepared, and basically the AI only accesses this set of tools and not the raw data. So it's enabled us to restrict a little bit what is exposed and what not. And the second thing, which is a big enabler for the project that Assad is presenting, is basically index of tensor, so tensor or vector, you can see it as the same way. And we put basically the capabilities for GreyCat to execute machine, so large LLM, to do embedding and to say from a query, we transform it to something which is a semantic vector, and this semantic vector can then jump into the database to go further. The major thing between other technology here is that for us, vector is one entity to our graph, but we have also all the rest, the time series, the rest of the relationship with the graph. So it means that you basically use a semantic search to enter the graph, look at something which is semantically close, and then you continue. You explore the rest of the graph, the rest of the time series. And this is what we did with the code, because we can say we look for something which is an event which is close to the semantic query we have, but then can go in the time series and look in the past and the future, look for the judge which are connected to this event, and so on. So have basically a direct navigation. So yeah, that's the two enablers of what we are showing today. That's the two new features of GreyCat 7, which is now in the core.
Okay, so for the demo of the court, this is a public demo. Basically, there is no sensitive information here. It's the court the document that has been already published since some time. I will start by showing a little bit the statistics of the database, so you can have an idea of the amplitude of the problem we were facing. So the database of the Court of Justice is around 16,000 cases. Basically 16,000 documents, more or less one document per case. The document have several sections, so from this 16,000 documents we have 330,000 sections, And then the section have some chunks which total 1 million chunk, and in these chunks we have text which total 500 million character. Okay, and you can see the graph forming because the case has a document, the document has sections, and section has chunks, and chunks has character, and you can navigate in this document, and this is purely the technical structure of the documents. But as well, one case, what is one case is, for example, a company A attacked a company B in the court and created a case. So in total, we have 25,000 parties involved around this 16,000 cases. And a case is being judged by one or several judges. So in total, in the database, we have 1,500 judges. We have 200,000 index term on the case, 26,000 keyword, and the cases goes from 1954 to 2025, so 70-something years. Okay, and as you can see here, you can imagine, first we have the scale of the data, it's big data. We have as well the graph aspect because things are related to each other. The case is related to parties, the case is related to judge, it's related to the index term. We have as well the time aspect because the cases are indexed in time. And we have the vector aspect because at the end we want to be searching for text. So we want to search, for example, show me all the cases about pollution in Luxembourg. Okay. So this is when we index everything in a GreyCat unified database. We have a graph of 1.7 million node and 3.2 million relationships. Where these numbers come from are from all this, everything is a node. And when you have a relation, so for example, a document can have 3 sections, and this adds up to 3 relationships in the graph. Okay, so these are the business concept, and these are the technical graph behind it. So 1.7 million node and 3.2 million relationship, it takes 53 seconds in GreyCat to create the full graph. So this is around 100,000 records per second in terms of import speed. We index the 16,000 documents in 72 years span, and it takes to index all of them 5 milliseconds. And we index 1.3 million vector, which is different text we have, and it takes around 56 minutes to index this vector. So basically, if you add up all this time, within 1 hour, we have the full knowledge graph indexed at the same time in relation, in time, and in semantics. The CSV size, the CSV source of data is around 70 gigabytes, and the GreyCat full disk usage is around 22. The compression here happens because GreyCat has smart way. We don't replicate data. Since it becomes a node in the graph, so we don't need to replicate the judge name several times. Since it has a unique ID in the graph, we win a little bit in the compression aspect. So if you want to see the CSV of the dataset, it's around 5 million row and 85 columns. And this creates the 1.7 million total node I presented before and the 3 million relationship. Okay, so here I will not go into detail about the different statistics of the judge, of the importance, of the legal types, of the type of the cases, the plaintiff, the defendant. All of these are just statistics to show what is inside the database. Okay. Yeah.
Didn't you mention at the very top that the number of characters was 500 million, like 500 million?
Yeah.
How can the whole DB consume 70 gigs on storage?
How come?
Well, you have 500 million characters.
Yes.
But it takes 70 gigs
yes.
storage.
Mm.
How is it possible?
Because the character is 1 byte, basically. So 500 million is 500 megabytes if you want, more or less.
That's what I'm calculating.
But you have as well the relation and the nodes and all the other information.
Oh, so that's the DB once you have processed it through...
No, this is the 500 million is purely text.
Yeah,
okay.
The flat data.
The flat data, but you have as well that, for example, this text is indexed in this case.
Oh,
yeah, so you have all the meta information around it, and this is what...
Actually, this number is quite interesting because it means that from quite a small number of characters or basic text, if you look at all the relationship, especially the semantic relationship between the element and the vectors that we have to compute, the size is tremendously bigger. And here it's still a kind of a small data set, if I may say. So it shows that whenever you build this kind of knowledge graph, the size is quite amplified by a factor compared to the original data, just to make sure that everything is pre-computed ready for the job.
But isn't the relationship for graph
Not only, but
more than linear as you grow the number of nodes? It's usually quite exponential, more than linear.
yeah. Here what takes most of the space is, for example, even if you have a small word, when you convert it to a vector, the vector is 1 megabyte already. So even if you have 1 byte of text, you can have 1 megabyte of vector to put it in the semantic space. Okay, so here what in this use case, if you take just the CSV alone is not big, but if you take as well the indexed vector for the, because for example we can say I don't know, the case is about pollution, and this is just 5 bytes of text, let's say, or 10 bytes of text. But once you convert it to a vector, the vector itself can be 1 kilobyte or 1 or 10 kilobyte according to the dimensionality you have, because you can have 1,000 dimension per vector. So this is what consumes a lot of text in this context, in this application. Okay, so if you see here in term of size, the graph and temporal aspect, I think when we import, it's less than one gigabyte. But with the moment you add the vector database, the vector database itself adds 20 gigabyte on the storage, because basically every byte of text is kind of expanded to give the semantic meaning for the text. So we can see as well, this is a kind of the most frequent term. So we have as well an index for the most frequent term. And another reason why the space can explode in terms of size, because the same document can have a lot of meta information. The same document can be indexed in time, in relation, in vector space, in statistics. So for example, here we can click on an article and we can see immediately how many times it appears in the whole database. And all of this information add additional pressure on the storage, because we don't want to calculate them on the fly. We want to pre-calculate them, store them in the graph. So when you ask a question, everything is pre-calculated and fast to reply. Okay, and you can see here the time distributions, the document distributions throughout the years. You can, in the early times, there was not a lot of digitalization, and with time, they start to digitalize everything. So we have more cases because the population is growing. So yeah, so you can see the time, and we don't have only one time index. We have, so for example, several time indexes, because it can be for the case when it was open, or when it was judged, or when it was published, or when it was filed, or when it was decided. So for every document, we might have several dates, and we want to index them according to several dates. And this again creates more pressure on the database, because the same document you can index it in several places. So this is an overview on the data itself. If someone has more question, or is it clear overall? Yeah.
Do you have some idea of time it takes to compute those dashboards you just saw?
The dashboard?
The dashboard, yes, the time index and stuff like that. Or are they pre-computed? Or?
So this is the import time that we have.
The data ones, the vitamin, yes, those data summaries.
Yeah, so here they are already pre-computed. That's why the reply is much fast. But the pre-computation time, it happens on the import. So what happens is basically we have the CSV, which is the raw data. And in the first step, when we start the GreyCat server, we import this raw data and we pre-compute all this kind of index, the vector index, the time index, the relations, the graph. And this is what contributes, because if we see here, what happened is that the CSV and the embedding is 70 gigabyte, and we pre-compute everything, and then in GreyCat, the same 70 gigabyte are represented with 22 gigabyte, but everything is pre-computed. So when you visit this website, GreyCat will reply to you directly with the statistics pre-computed. Okay, so it pre-compute, for example, as well this year distribution or the distribution per judge. We will see more further. Yeah. Any other question on the data before I move? Okay, so of course, of course, we can take this CSV, which contains 5 million row and 85 columns, and just put an AI on top and start asking questions. The only problem with this approach is that each time you ask a question, the AI will go through the CSV. It will take a lot of time, and it's not efficient, because either it can generate some script to try to calculate things, but each time you try to do it, it will be like around 20 minutes of calculation just to answer a simple question. And this is not what we want. So some of the questions we want to know, for example, how many times this party has been sued, or how many times this topic has been present in the data, how many times there was cases about pollution, or cases about traffics, or different kind of things. And we don't want to open all of this CSV each time and go through on each question. So the way we do it is we create all this index in GreyCat to be able to reply very fast when a question appears. And here I would like to go to the Graph Explorer to show you, instead of having a CSV, we have the graphs that is indexed in a smart way. And what does it mean? It's like when you open a big encyclopedia, you don't have to go through all the pages. You have the first 10 pages are the index, which can tell you where to go to find the information. And here it's the same. So we have these entry points that are on the top level. So we can enter through the documents. We can enter through the cases. We can enter through the judges. We can enter through the parties, through the index term, or the keyword, or the citation. Okay, these are the entry point to the graph. And what does it mean is that, for example, if I have a document in mind, I have a reference in mind, and I want to navigate through this reference, for example, 785. Okay, and then I see all the document with 785, and then when I click on it, I can see the section, I can see the subsection, I can see the structure of the document. And of course, we can do the same for the cases. And then when we see the details of the cases, we can see the judges that were in these cases. And here you can see clearly the graph navigation, because from the case, I can see the judges that were in the case. Then I can click on the judge. I can see as well the different keywords, the different documents that has been indexed on this page. And then from the judge as well, I can see all the other cases that this judge have done in the past. So I can see all the other cases. I can see as well the timeline of the judge. Okay, I can see all the different cases. I can see the topics that this judge overall is expert on. And you can see how we can navigate in the graph, because we can jump from one concept to another ultra fast. Okay, so and we can navigate not only on the graph, but as well in time, in the timeline. And in order to achieve this, we have created all this high-level index, and inside we have as well the time index, but as well we have the vector index, which allows to, for example, search for a certain topic, or with different type of searches that exist. For example, if we want a legal search, we want the exact term match. If we are okay to find similar term, we can do semantic search. And to allow all of this to happen, this is where GreyCat GreyCat is doing in the backend, is offering all this kind of API. So the same things that you saw visually, we can do it programmatically. So we can see all the different API related to the case, all the different API related to a document, or to a judge, or to a party. And these APIs, what they mean is that a program or a computer can basically query and get the information. Okay, so for example, here on the case, if I put a case ID and I execute, I can get the information of the case. Okay, and you can see the speed of response time, and this is, you have to compare then opening a full CSV and try to search inside. Okay, and if we benchmark, we can see the different run speeds. Sometimes it's faster or slower, but all of them are replying in less than 20 milliseconds. And what this means is that This speed is when the AI, for example, call GreyCat, I want an information about this case. GreyCat will be already preparing everything to reply very fast. So then it allows the tool to be able to call several times instead of just calling one and waiting 10 minutes. Okay, if we want to see the speed on over all these APIs that we create, in total we created 81 endpoints, and from these 81 endpoints we can benchmark them even live, and we can see the response time of most of them are ultra fast, less than 100 milliseconds, less than 150 milliseconds, and then we have some APIs that takes 1 second or 2 because these are that need, like, for example, vector search or embedding calculation, and this is the heaviest calculation that needs, and this one reply in 1 second. And what we are promising with this technology stack is that whatever tool you put inside, it's very fast, and it can reply to you in a quite amazing fast time. While a similar technology with 5 different stacks, because when you have an orchestrator and 5 different stacks, the orchestrator will receive the call and then will call another one, then will call another one, and then to aggregate the information, they used to reply in 10 seconds or 20 seconds or even more. Now the last point I want to talk about this before this is the only technical part, and then we can go more to the demo, real demo aspect of it, is that as I said before, is that the security and access control is can be done on each of these endpoints. So for example, we can say the judge endpoint, only the judge can access them. Okay, and since we have one database here, it's super easy to say these endpoints belong to the judge and no one else can access, or we can put the same access control on a specific document, or the cases that are ongoing, we say only the judge can access them. And this, what it means that if you log in here as a judge account, you will see more information, not only in the UI, but as well if you go to the chat page. Because your chatbot will inherit your token. The chatbot will inherit the token and will have the same access control as you. And this is the important part, is that if you do the security and access control layer in a correct way, not only it applies to the UI. So for example, let's say I log in as a normal user, maybe I will see 16,000 documents. But if I log in as a judge, I will see 17,000 documents because I have access to 1,000 documents more. But not only me, as a user just looking at the UI, is as well as a chatbot. When I go to the chatbot will inherit my permission and then will be able to search through more documents than if I log in as a normal user. Okay, so this is very important. Now, not all these endpoints needs to be accessible for the chatbot, for example, and this is where the difference between an API and MCP. So from this 81 endpoint, we said 37 MCP enabled. It means that 37 out of these 81 are interesting to be accessible by a chatbot. And here, when we see which endpoint are, without duplicating the code, without duplicating the functionality, it's just as Francois showed you before. You can tag the API as MCP, and then the chatbot will access only this 37 MCP endpoint. If we go to the chat page, we can see it here, 37 MCP tool enabled. Okay. Anyone has question on the API? Yeah.
So the MCP in this case is a group of endpoints.
Yeah.
So
it's a subset.
The definition that you do there, you say there's MCP and you say you have a tag for a specific MCP.
Yes.
Then they group.
Basically, we create the same API, but some of them we say this particular API, for example, here's a case search, we say this particular API is as well accessible through MCP. Some other API, for example, user management, we don't want the chatbot to access them. We don't want that someone just go in the chat and say, create me a judge account. Yeah. So then for security reason, we say, okay, this endpoint, maybe we don't want it or this functionality, we don't want it to be accessible via the chatbot. We just remove the tag MCP on it. So only the useful one, for example, the chat application here is about to search in the document. So you don't want the API related to user management or security to be as well accessible in the chatbot. And as well to reduce the number of API to the chatbot.
Yeah. Then another question not related to this one. The second is the chunks. The
Mhm.
definition of the chunks. How do you define the chunk size?
This they did it, the data science team of the court, they have their own definition based, so the definition of the chunks, it's based on the legal document, and the legal document have some kind of structure, and they
Okay,
define
the
the
knowledge of their
Yeah.
makes sense.
yes. So here we just take their definition and we enable, we didn't do anything on this topic.
The last question, like, what is your take between, because a lot of you showed in the statistic mainly and other stuff, it really looks like a typical data warehouse way of navigating the statistics or showing the data.
Mm-hmm.
And what's the biggest advantage of the GreyCat compared to the data warehouse in this case?
The biggest thing is that what we presented before is the security, the synchronization, the management, because you need one system and you have everything together instead of having several subsystems, especially in the indexing, because you can index in several ways the same data.
It's the main thing. It's a graph, actually. So since it's a graph, naturally you can connect a bit of everything to everything. So we can connect church to cases, cases to article or chunk, and all of this is a lot unlocked by the graph.
Mm-hmm.
So basically here GreyCat shine because it's a graph database. It's not the only one to be a graph database. Graph databases are by nature the best kind of tool to build a knowledge structure, which is basically the input now for MCP or AI. The advantage of GreyCat here is also we have time series. So we have immediately the series of the movement of the judge and the number of elements. So we have the capacity to have this index also in time. And we have the vector database as well. So it means we have also the relation between the cases based on the semantic closeness approach.
Okay.
So it's
That's
the aggregation of those three tools makes the construction of this data warehouse pretty easy, simple. It's possible to do it by assembling 2 or 3 stack, definitely. But where we thought it will be very useful is once you do this and you have this pre-crunching approach to make all the API reply fast, plus MCP, it starts to be a very good enabler to build a search engine. So all of this here is just to show here what is below. But of course, the real product is just the search and the chat.
Mm-hmm.
People are absolutely not interested into this to navigate. And the reason why we do it here is that the people understand as well how we build the search engine. But what you want to see at the end is like the search of Google.
Mm-hmm.
It's nothing else.
Mm-hmm.
The rest is completely hidden.
So, if I understand, compared to a data warehouse, big advantage here is that you've got a dynamic modeling.
Yeah.
Basically, is that.
Yes, and then
Data warehousing, you've got dimensional modeling, Kimballway, static.
Yeah.
Okay. But the data warehousing, one of the main advantage, technically, is recalculation or calculation of the aggregated value.
Mhm.
It's just, so, and as far as I know, most of the time it's one of the weakness of graph database. So about aggregating values, performance, where are you? Are you closer to a data warehouse or are you?
We are closer to data warehouse, I would say.
Than
Just
to-
the reason is there is graph database which follows strictly the graph terminology, meaning that they are here to do kind of pattern matching or aggregation queries. Like if you think about a language like Cypher, you start from the point and you say, okay, match everything which has this kind of criteria, this kind of attribute or relationship around myself, because this is the kind of graph queries people are used to. GreyCat is more an object-oriented database. You can build a relationship and you can build collection on the fly. And so you can dynamically extend any kind of pre-computation and create links which are here to serve the API. So it's not strictly related and strictly limited to a graph structure. It's more the way we usually program objects for programmers, which is now persistent.
So the capabilities to compute aggregated data.
you can as well store the aggregated data in the graph, and this is what we show here.
Basically, the pre-computed.
You pre-compute them.
Yeah.
You don't do it on the fly.
So if you click, for example, on
Depends. Okay.
Depends.
Because from the graph I've seen just before, there was a graph. Okay, on one of these graphs, if I select a value here, for example, and I make a filter on this value,
Yes.
it will, does the filter will be able to completely go through the whole model? So you've got also data discovery capabilities, a little like click use or...
So you see it here. If you click on, you see the relation. For example, one case is related to another case and related to another case. And then when you click on the relation, you can see the case. And then when you can click on the judge. And then, for example, when you go to the judge, this timeline is pre-calculated. Is not it was not in the data, but just deduced from all the documents that this judge treated within the time.
So the calculation of the aggregate
can be done at the import. Can be done dynamic. Yes.
Can be static.
Oh, static.
At import based on the speed.
Yeah.
So if we go back to the graph, I'm sorry to monopolize it, but if we go back to the graph, let's say that, for example, I select a point, then I can make a filtering that is crossing the whole data model. By selecting a value. I want only this value, so give me all the related. But then I make an exclude.
Yes.
For example, I select.
And so when we say always yes, I have still to mitigate, is basically GreyCat is database and a programming language. So it means
for the users, for example, it does mean that if I said, okay, I want everything related to this point, but I don't want anything related to this other point.
Yeah, but
you can make an exclude.
This is what's happening here. If you filter, if you want to filter, you can say I want all the type of document, or I want only the hearings or the judgment summary. So you see the filtering of the graph happening dynamically.
But here you include, but can you exclude?
Yeah.
I don't want.
Yeah.
It's not, for example, I want only the one that is non-published.
Yes.
But I want only the ones that are not published, but
you can have
the ones that would be...
yeah, it's basically, okay, in this demo we have the filter by type, but you can add as many filters as you want, because if you go to the search, you have different filters. So you can have by the document type, by importance, by element type, so you can select any combination of this, and it will be filtered automatically for you. Just because we
just do a tiny break, is because Cyril is mentioning with good right, the pizza are cooling down. We are about to show you a few chats and a few vibe coding that will be pretty long. So what we can do is now to make it more dynamic, so you can go help yourself, take a slice of pizza, come and discuss, and this way we can now jump on the question and make it less streamlined.
So maybe, yeah, exactly. Before we go to directly to the question, so the whole goal of all this, what I was showing, is basically to reach this chat page where you can see the 37 MCP tools, this MCP tools that navigate in the graph and time and everything. And you can ask a question like, summarize me this case, or how many times Microsoft was mentioned as a party. And then the AI, you will see now, will be calling all the different APIs that we have in the database, and according to what we ask as a question, he will decide which tools or which API to call, and then filter out. And you can see here, he did a query, it didn't work, then he query parties. You see all the tools that he called, and you see the ID. And the interesting part is to be sure that he's not hallucinating. You can click on the document and you can see that it's a real case, and you can see all the documentation, and you can see Microsoft is being involved here. Okay, and so this shows you the link between the chat, the APIs, and the graph. You can click on a reference, and then from this reference you can see the judges, and you can go directly navigating in the graph, or you can go to the chat and ask, give me more detail about this case. And again, it will call parties and stuff. So, as I said here before, the AI can call any of the MCP tools. Vinny? Okay. So you can see as well, when you ask a question to the chatbot, you can see the tools that has been called and the answer of every tool, and you can see as well the final the final answer. And the important part is that we created a way to link directly whatever you see here to link it back to the graph. So you can click on any link and you can see the case, you can see the detail, you can be sure that the AI is not hallucinating, that this case is real, with all the details. Now, of course, for the AI part, you can use a cloud AI or you can deploy it locally. And the local deployment is just about if you have hardware dedicated for models. Here, about the local deployment, the AI part, I get now many questions about the AI models. All we require is that the model is basically instruct enabled or agentic model, what they call it. And agentic model, it means that the model can call external tools. If the model can call external tools, then it means it can call GreyCat, and this is what we show as well on the API page. By the way, this demo is public, cgeu.greycat.io, because I get as well some other question. If you want to see it on alone by yourself, you can visit this. And for the API, you can see we don't need to have even a UI for the chat page. You can just add this link here to Claude or Codex or any agentic AI you use, and then you can start asking questions the same way as we do here on the chat. Okay. Of course, since here all the data is public, we can do it. But of course, for sensitive data, what we recommend is that we don't expose this to the public as we do here. Either it should be behind access control, and then this is as well some stuff that I was talking about, that if you log in, you might have access to more documents, for example, or if you have an authentication token in GreyCat, it can allow you to access more document or more sensitive information than the public, according to your role and your security or access control. And by transitivity, your AI is the same. If you give this token to the AI model, then the token will have the AI will have the same capability and can access more documents. So that's it for the CGEU demo. I don't know if someone has more question about it before we move forward. Okay. So as you can see, it was 16,000 documents, around 400,000 chunks, 1,600 judges. It has the multi-index, the different search mode, the citation network. It's AI ready. It means 37 MCP tool can be accessed by AI. And it's sovereign because you can deploy the whole solution locally, and you can even deploy the AI part locally and have this everything in a bunkerized environment. Now, in order to do even this demo itself, we used AI to vibe code it. So this demo you see here is fully vibe coded from end to end, from backend, front end, MCP. And to do this, we have as well skills for GreyCat, which is a GreyCat skill that allows any AI to generate GreyCat code or generate the graph. And here I will show you a quick demo about it. So I wrote this following prompt: generate me a GreyCat graph for the Court of Justice, where you create types for court case, involved party, judges, judgments, documents, section. Create the full bidirectional relationship between the entities, and show me a short summary of the different entity you create. And then it starts to generate the GreyCat code, and it generates the different types and relationship between them. It consumes some token, it consumes some times, but at the end, I will show you the different graphs that was generated. And from the GreyCat skill, we have as well for the agent, it has all the instruction how to compile GreyCat code, how to make sure that the generated code is correct, how to test, how to benchmark. So all of this is accessible.
It's mostly here where we show how we build this. Is the advantage of GreyCat is a program. It's a database that you can program. So basically, in terms of expressivity, we can go a lot further with the database. The downside of this is you need to program the database to to express the queries that you will basically offer and navigate. With LLM in general, we now bridge a gap between the two worlds, because with description we can assist people to write the part of the code which exposes the graph and augment very quickly the database that will be then generated and have the best of the two worlds. It means that everything is computed in a program and pre-crunched, so we don't have the limitation of database, yet it's still easier to access for many developers because of this natural language description which serves as input.
So as an example, you can see the generated. Of course, it's not like as simple as that, just one prompt and that's it. We had to do several iterations. We have to make sure that all the generated code is correct, but it accelerates a lot, because you can see here the first generated entity and the relationship between the different types makes sense. So it creates a document, a judgment, a judge, the court case, and the court case has document, has judgment, has judges, and the links between them. I mean, okay, this is just a quick generated graph from the prompt. Of course, it's not the end product. We have to iterate several times, and we have to make sure it aligns with the data that we have. But it shows as well the capability to generate a complex schema of relationship between different entities. So,
yeah.
The last news, maybe I give the floor back to François.
I will be very quick, but it's a first meetup, so we just have to start somewhere to disclose the kind of feature which enables this kind of application. What we did recently in GreyCat is essentially write on the multi-write. I mean, we are one of the only, not the only one, but one of the very few database which can write in parallel at the same time in different places of the graph. And so we enable this via task and job. And so we have a strategy that even if the graph is kind of a consistent structure, I must say, then we have ways that we can make this evolve, especially for the time series, in parallel at the same time. Then we also made our type system evolve, so it means that the typing that you saw here is also propagated now even for the front end, even for other languages such as Python, TypeScript, and Rust, which means that even if it's a human or an LLM which codes, it will rely on those type to basically have not only some opaque object or JSON object which arrive through an API, but something which is typed from end to end. So yeah, I will not go into the details, but we basically matured the different tools, especially GreyCat installs, the repository, the full JSON API support, to open this to other usage, especially the Open API support was requested since very long by many users. So now it's the case, which means any API written in GreyCat is exposed in MCP, but also in Open API and can be consumed by other subsystems. So for us, it was really important that we can describe tools, but also tools which can be consumed by the rest of the IT system, and not only by the kind of dashboard we see here for the demo. We have just some number to share because we were happy of this. We benchmark GreyCat regularly for the speed. We spoke a lot about API and speed. The speed is important to enable case study, especially when we speak about pre-crunching data to make the API faster. We are pretty happy because we had the chance to work with Melusina HPC, and especially to take one of the nodes to build a little bit of record for our ingestion speed. So we are now at 320 million per second by taking a single node. So to give an idea, for the Kopr, the ingestion of free of data went from several hours to now less than 1 hour. So it's almost 48 minutes. It evolved. I think Mark will probably say we will have to redo this benchmark regularly. But the speeds we are disclosing here show basically this change of magnitude. It means to restore a system, it can now jump from almost a day to something which is less than 1 hour. So it means that really this tool can enter the critical path. It also means that very small devices like a Raspberry Pi are really capable. I mean, now we can reach million per second, and we have a partner, an industrial partner here, which also leverages this kind of hardware for Industry 4.0 use case. And reaching this speed here means that we can now augment the frequency and record more data, such as frequency analysis that we barely process today, but which could now be a lot more easier in the future. So that was it for us. We have still 10 minutes. We have dozen of questions that we prepare, but we essentially wanted to exchange with you.
So there is one question. Yes, sorry. Can it be distributed? Can it be distributed?
You mean GreyCat? Yes. The distribution for GreyCat at the moment is rather simple in the sense that we most of the time use quite large node and we do mirroring. So it means that we use mostly high availability principle rather than distribution. We now work on a national project to go more for the distribution of the graph, so it means to shard a little bit the computation. It's not part of the release yet, but this is a roadmap of the next 2 months for us. We postponed this as far as we could because actually we were quite sure that by taking big machine with many cores like this one of Medusina, we can already achieve very big large end computation. We now think about distribution, especially if you want to do some long-running jobs, such as if you want to do some embedding or this kind of computation of connection between the vectors. Can take several hours, and it's not a good idea to basically take the cores which are normally here to reply for the API for this. And so we use this to spawn the very long task on another machine, and can be even dynamic. So it means that it could be a central machine and another one which is spawned on the fly, just to activate those computations. So it's definitely on the roadmap. Today, GreyCat is quite monolithic. It's built in a way that one machine can already handle very big pack of data. Then, what's your question? I mean, is this Unify graph and chat link, which is connected to the real data, something which could be valuable for your company? And if not, then it means that you think that the chat alone will be enough, and then we are very happy to discuss this with you. What's your feeling? I mean, don't hesitate to even just say, yeah, my domain will be fine or not, or if we do a round table in the room. We'll start. No, doesn't ring a bell? Go for the next question. No usage of graph in your industry? Not yet. It's what okay. Is the sovereignty discussed in your industry? Is everything what we discussed about bringing back AI and the data in a sovereign storage is something which is today discussed in your industry? Yeah? I don't know, of course. On the precedent question, no one replies. So yeah, it's and is there a plan already to do this? Is it already in place? Did you already discuss the local deployment of model? Did you already evaluate the size of model and the cost of hardware, or is this really fresh new?
I would like to know.
It's pushed over as long as it.
Okay. So it's still discussed, but at the moment it's not on the active roadmap, right? Okay. Then we just wanted to prepare this kind of thing because we discussed this with our partner, the cost of hardware. So we prepare a tool to try to anticipate. There was many questions to Assad about the size of model and what kind of local deployment, the number of MCP APIs they can handle. We don't have all the answer yet, but we try to experiment and to see, especially on the case of the Courtier with this 38 MCP API, we started to try to shrink down the model and see how small it can be, and to have an idea in terms of what and in terms of cost, what it could be. And it's interesting because, for less than 10K, basically, we could have hardware. So it's something to keep in mind for the industry if it starts to be discussed that we are not speaking about very big investment to bring back some chatbot like this. If we are speaking about connecting to prepare tools, if we speak about connecting to raw data, this is a different story. But to prepare a tool like the one we are discussing today, it can be a pretty reasonable hardware up to our test. Right? What tools or question you would like this AI to reply? I mean, here we show the stuff for the Court of Justice. where you would like this kind of tool to go in the future? Is it something where you would like that they replace your BI, your dashboard, or whatsoever? Any feedback on this? No?
Maybe I can give you some ideas. So in the manufacturing sector, we have some operators asking what could be the scrap rate of a specific station on a specific machine at a specific time.
Yeah.
It's more related to basically statistics on the raw data we have in the database.
Okay.
Things like this.
So if I understand well, they ask to have access to statistic data, and they think that the chatbot could give them more easily access than dedicated tool or dashboard or this kind of thing, right?
Today we have graph.
Yeah.
Dashboard.
Yeah.
But some operators are not able to read the graph.
Yeah.
So if they can chat directly with the data, it will be easier for them to understand
Okay.
what they need to.
So we could have a broader audience with this rather than just the dashboard and analytics that we have for the management at the moment.
You know, for the demo of the court, it was a similar problem because basically, as we said, at the end, the AI has access to the same API, and all the API will provided they have as well the dashboard on the UI you saw, because any information you want about the data is already existing. You can either navigate on a case or on a judge or on a topic, and you can see how many times this topic has been mentioned, for example. But somehow people, for example, there is a dedicated tab for topics, and you can type any topic and you can see it's directly mentioned in 2,000 cases. But somehow people would prefer to go to the chat page and ask how many times this topic has been mentioned, and the AI will do the same job as calling the API, getting the answer and replying nicely. We're fine with both, but of course with more complicated systems, the number of API can explode, and no one would like to go and search or search through the menu. Then the chat is becoming more useful and more natural.
Okay, then more broader audience. So from the previous, I understand that this one is not yet in place. Have you already the problem of maintaining several databases? Because here we said this is an advantage, and we also discussed with different partners, and some has already not yet synchronized the data sources. I mean, Creos cannot say no because we have the GIS and the status files that we already do. So we have already this question, but is it the case for other industry? Are you already synchronizing the different database in your data warehouse? That's a no. Yeah, I mean, the rest is more advanced question. This is a more tricky question. At the moment, everything we show here is read-only. AI access the data, navigate through the API. I mean, GreyCat API can do read and write. Can we open the door? Should we? And just saying that technically on GreyCat now we just have to remove the read-only pattern on the function.
You have full changelog?
Yeah. The data is historized, so we have kind of a Git on the data, so we could see what has been done. But just saying that we come to this question now. I mean, this is really for the Court of Justice. It's kind of easy. But for example, we start to have now some industries that want to have kind of a write back, especially if we speak about an agent that look, for example, for proximity product and need to comment or need to create an event on this. Eventually, we could do it automatically now. Is it something which could be interesting or scary?
Amazingly interesting, but under with care.
Mm-hmm.
So, in such a case, is there is any possibility to sandbox?
Yep. Yeah. I
Even
mean,
maybe not in versioning, but at least to sandbox.
we have already access control, such as we are doing through API. I mean, here we have the legacy inheritage of all the experience with API and access control and limitation, for example, for the subset of data that we can access or modify. So this is basically inherited from this. And MCP, like any other API consumer, will have to define this. Now for the sandbox, the thing is, to be useful, this kind of thing need to access the data as well, need to access to action. So there will be sandbox to not do tremendously something out of control, but they will still do things. Like if it's a system, if I take an example, if an AI can basically say we can plan an action physically, so we put this in the system, so it means that at the end someone will take his car and try to do the action here. If it's a verification for a cable, for example, this will have a real effect actually, and this is not really related to the IT sandbox. It's more related to the validity of what has been said. So it will be a question because the AI at the moment is a little bit, it's more and more precise, but it's still kind of with a bit of randomness. So we start to open this door here, but at the core, DataThings is doing system to take operational decisions. So we now ask who is interested to go in this direction, or should we basically first go further for the analytics in read-only? It's more a philosophical question that we wanted you to take away as the last one for today. But think about this and tell us if you have a case study where it starts to be a real question for this. Okay? I think we promised to finish at 2. We will skip the rest. And yeah, thank you for your participation.
Thank you very much.
Hope it was still interesting for the first event. So we will try to organize this more regularly. Join the Discord if you want to discuss with the team. Especially if you want to try GreyCat, you can go to greycat.io and install it on your machine. Community version is free and can be already used pretty extensively. So please try, install it on your machine, on your case study, play around, call the team if you have an issue. But yeah, we want everything to move. So thanks again, and I wish you a good day.